Here, tau is the time it takes for the superposition to collapse on its own. H bar is the reduced Planck constant, a fundamental number in quantum mechanics. And Eg is the gravitational self-energy of the superposition, a measure of how much the two separated versions of the mass particle are pulling space-time apart. The equation shows that the lifetime of a superposition is inversely proportional to its gravitational energy. A larger, more spread-out superposition with a higher Eg will collapse faster. A smaller, more compact one will last longer. This provides a physical, non-random clock for the universe's state selection process. This is the heart of the physical claim. It proposes a new law of nature that bridges the gap between the quantum world and the world of gravity. It asserts that there is a specific calculable timescale for the collapse of any given superposition determined by its mass distribution. This isn't just a philosophical interpretation, it's a concrete physical hypothesis. If true, it means that gravity, the force that shapes galaxies and orbits, also plays a fundamental role in shaping reality at the smallest scales. And according to Orch OR, it is this very process, happening over and over inside our brains, that creates the flow of our conscious thoughts. So, the final step here is to connect the physics of objective reduction to the biology of microtubules. The Orch OR theory proposes that quantum superpositions of tubulin proteins within microtubules are the source of the gravitational self-energy, which is called E-G. As more and more tubulins join this coherent quantum state, the total mass involved in the superposition grows, and the Eg value increases. According to the equation tau equals h bar divided by Eg, this means the collapse time, tau, actually gets shorter. The theory suggests this process continues until tau reaches a timescale that's relevant to neural processes, like, for example, around 25 milliseconds, which matches up with those 40 Hz gamma band brainwaves that are often linked to conscious perception. When the collapse threshold is reached, the quantum state inside the microtubules undergoes objective reduction. It snaps from a state of multiple possibilities into a single, definite classical state. And according to the theory, this physical event, this moment of gravity-induced collapse, is a moment of conscious experience. It's like a discrete frame in the movie of your consciousness. The continuous flow of our awareness is proposed to be a sequence of these individual, objective collapse events, kind of like the frames of a film reel. Now, the orchestrated part of the name refers to the idea that this process isn't just random. It's guided, or orchestrated, by the computations happening within the microtubules, which select specific outcomes that end up influencing neuronal firing. This model, honestly, provides a narrative for how consciousness happens. It starts with sensory input or internal processing triggering quantum superpositions in microtubule tubulins. These superpositions evolve and compute, linking up and growing until they reach the Penrose OR threshold. At that point, gravity intervenes, collapses the state, and a moment of conscious awareness occurs. This collapse then influences the classical behavior of the neuron, causing it to fire or not, and that in turn affects the rest of the brain's network. So, consciousness, in this view, is not just an emergent property of complex classical computation, but an intrinsic feature of the universe, a sequence of discrete physical events tied to quantum gravity, harnessed and orchestrated by our neural architecture. It's a breathtakingly ambitious synthesis of neuroscience, quantum physics, and cosmology. It paints a picture of the mind as a finely tuned instrument, playing a cosmic symphony where the notes are moments of reality itself being chosen. It suggests that each conscious moment is a selection from a platter of quantum possibilities. A selection governed not by random chance, but by a deep connection between the matter in our heads and the geometry of space-time. This is no longer just a theory of the brain. It's a theory of reality, with the conscious mind playing a central active role. The most profound implication of the Orch OR theory is that consciousness, if it really does arise from this process, is fundamentally non-computable. The reason for this lies in the nature of objective reduction itself. The outcome of the collapse is not determined by an algorithm. While the evolution of the quantum state before the collapse is, sure, computable via the Schrödinger equation, the collapse itself, according to Penrose, contains a non-algorithmic element. He speculates that this might involve influences from the very structure of space-time geometry, a level of physics that's just not representable by any Turing machine. In this view, the universe isn't just carrying out a massive computation, it's doing something more. Something that involves a form of understanding that's embedded in its physical laws. This non-computability, Penrose believes, is what accounts for the special quality of human insight, creativity, and mathematical intuition. A digital computer, no matter how powerful, operates by executing a predefined set of rules, an algorithm. It simply can't step outside those rules. If Orch OR is correct, then the brain is not bound by such rules. Each moment of gravity-induced collapse taps into this non-computable physics, allowing for genuine flashes of insight that aren't just the logical output of a previous state. This would mean that human consciousness possesses a quality that artificial intelligence, as we currently conceive it, could never replicate. We could build machines that are incredibly intelligent, but we could never program them to be truly conscious. This creates a stark, dramatic dividing line between humans and machines. In the computationalist view, like GNW and IIT, consciousness is a difference of degree. A sufficiently complex machine could cross the threshold, but in the Penrose-Hameroff view, it's a difference in kind. Consciousness depends on a specific physical process tied to quantum gravity, a process that is likely impossible to simulate. This would elevate biological life, or at least life with microtubule-like structures, to a special place in the cosmos. It would mean that the stuff we're made of is not just incidental, but actually essential to the nature of our minds. Our carbon-based biology would be a requirement, not just a historical accident. So the debate really boils down to a fundamental question about the nature of reality. Is the universe a giant computer and the brain just a smaller one running a special program we call consciousness?